Hi, welcome to DBMS course. Today we are going to start a new chapter called Normalization. And in this session, let me give introduction to normalization. What is normalization? Normalization is a database design technique that reduces data redundancy and eliminates some undesirable characteristics like insertion anomalies, deletion anomalies, and update anomalies. Let me explain each of these with an example. Suppose we have two relations. The first relation is student with the attributes student ID, name, age, and department ID. And the second relation is department with the attributes department ID, department name, and block number. Suppose department ID is the primary key for the relation department. So this is our primary key. And the student relation has borrowed the attribute department ID from the relation department. So this will be a foreign key. This is the scenario when we store the data in two relations which are linked via a foreign key. Instead of this, suppose we put the entire data in a single relation. Then it looks like this. So we have a relation with 6 attributes: student ID, name, age, department ID, and department name, and block number. Is that clear, sir? Then if we put the entire data in a single relation, what are the advantages and what are the disadvantages? The main advantage is the information retrieval is easy because the entire data is stored in a single relation. Then what are the disadvantages? The first one is redundant data. Redundant data means duplication of data. The second one is anomalies. Anomalies are mainly three types. The first one is insertion anomalies. The second one is deletion anomalies. And the last one is update anomalies. Let me explain each of these disadvantages one by one. The first one is redundant data. Okay. For example, in this relation, the first record and the third record and the fourth record are containing the same information about the department ID 101. So the first record contains 101 CSC block 1. Similarly, the third record also 101 CSC block. So the same information 101 CSC block 1 is stored in first row and third row, even in fourth row also. So there is a duplication of data. This is an example of redundant data. The next one is insertion anomalies. Suppose we are trying to insert a new record with the attribute values 66. Assume the name is PVP and age is 25. Suppose he is joining in the department 101. Then we supposed to enter the details like this: 101 CSC B1. These are the details which we supposed to enter. Instead of this, by mistaken, instead of B1, we entered the block number as B10. Then the first record is saying that the CSC department is present in block 1. And the last record is saying that the CSC department is present in block 10. So there is an inconsistency in the data. So this is an example of insertion anomalies. The next one is deletion anomalies. Suppose we need to delete the record 1 and record 3 and record 4. So we are supposed to delete all these 3 records. If I delete all these 3 records, then in the remaining relation, we don't have the details of the CSC department. That means we lose the details of CSC department. So this is an example of deletion anomalies. The next one is update anomalies. Suppose the block number of CSC department is changed from block 1 to block 10. So we need to update the records in which CSC department is present. In those records, I need to change block 1 to block 10. So I have 3 records: first record and third record and fourth record. So in first record, block 1 should be changed to block 10. Similarly, in third record, we need to change to block 10. And similarly, in fourth record also. Suppose that We forgot to update the fourth record. We forgot to update the fourth record. Then what will happen, sir? Record 1 will say CSE department is present in block 10, whereas record 4 is saying that CSE department is present in block 1. This is an example of update anomalies. So this is introduction to normalization. In next session, we will discuss about functional dependency and its types. Thank you.